connection between us and the universe. It allows us to gaze at the people we love, look at flowers, and experience the stars. But what is light? Let's take a closer look. How does light move? Well, today I'm going to attempt to tell you. The light that we see is known as visible light and is a small segment of the electromagnetic spectrum, a broad range of wave energy ranging from radio waves to gamma rays. Radio waves are what help you hear the radio, and gamma rays cause radiation, and somewhere in there is visible light. Here's an example of what the electromagnetic spectrum looks like. Radio waves are largest over here, whereas gamma rays can be smaller than a water molecule. But how does light move? Well, let's think. If you look at me, you can see this book in front of my face. That's because light moves in a straight line. It can't bend around this object to hit your eye. But there are certain examples when light can bend, using mirrors or reflections. Next, we're going to talk about how light bends. Have you ever been driving along in your car and you're driving and all of a sudden you look up and you notice a beam of light on the ceiling? Well, you're probably smart enough to deduct that somewhere in the car is a mirror or the surface of a cell phone or some sequins on a t-shirt that is causing this. But how can this be? We've already talked about light, and we know that light travels in a straight line. So how could light that's hitting your phone end up on the ceiling? Well, it has a lot to do with how light interacts with mirrors. Reflection is consistent. So the angle at which light enters is always going to be equivalent to the reflection angle, the angle of reflection. So we call this the angle of incidence, as at which it enters. So the incident ray comes in, and say at 90 degrees, it's coming in at 90 degrees, it's reflected back out at 90 degrees. And this is always consistent. So if the angle comes in at 90 degrees, it's being reflected back out at 90 degrees. If it comes in at 45 degrees, it's going to be reflected back out at 45 degrees. And light always behaves this way. It's quite predictable. So I hope you learned a little bit about mirrors and light.
Evangeline, what are you doing there?
Oh, I was watching you.
But how? You were around the corner.
Well, I have some mirrors, and this thing, it's called periscope. Some people use it in submarines, and they can look at things above the water. But that's kind of crazy, right? Like, how could you see things if they're above the water? Well, light travels in a straight line, and as it moves, it can hit things like mirrors, and the mirror reflects it at the same angle that it goes in. So when I look here, light reflects off of this, and it bounces up, straight up at the angle that I'm looking at it in the same angle to the second mirror. Why are you moving it? To the second mirror. And then I can see you around the corner.
Okay, but isn't that a little creepy?
Well, we're not talking about that. We're talking about science. As we talked about in the previous clip, periscopes use two mirrors to bounce light from one place to another. Inside the periscope, the two mirrors are placed parallel to one another in the direction that the one desires to see. This drawn periscope will allow the user to see in front of them. Light bounces off the first mirror, then the second to hit the person's eye. As I talked about earlier, the angle at which the light enters, the angle of incidence, is the angle at which it is reflected, the angle of reflection. So in this circumstance, light is entering at a 45-degree angle and being reflected at 45 degrees. When that reflected light hits the second mirror, it is again reflected at 45 degrees right into your eye. Thanks for watching. Hopefully you know a little bit more about light than when you first started, and always remember to be grateful for light, because without it, what would life be?